So this video is all about solving polynomial equations by factoring. Before we actually get started on the examples in the notes, I did want to point out that this is a strategy that we've already talked about when it comes to solving quadratic equations. So for example, if I gave you this equation, we now know a few methods for solving equations like this. One of them is just to apply the quadratic formula, because remember, the quadratic formula is designed to find the roots or the zeros of expressions like this. But we also know this technique that we used for quadratics, which was to factor the left side of the equation. Remember that whenever you have quadratics like this, which are called monic quadratics because that leading coefficient is just 1, we had the strategy for factoring these, which was to look for two numbers that multiply to give us this last number, so two numbers that multiply to give 6, and which add up to that middle coefficient, which is 5. And those two numbers in this case would be maybe 2 and 3. It doesn't matter which order you write those in. Remember, those are not the solutions, those are the numbers that you can write next to x in each of the factors. So in other words, I can rewrite that quadratic as x plus 2 times x plus 3, and then the right side of that equation is still equals 0. The benefit to doing this is that now we know, because this product of these two things is equal to 0, that means either the first thing is equal to 0 or the second thing is equal to 0. So that means that either x plus 2 equals 0 or x plus 3 equals 0. And that means that there are two options for x. Either x is equal to a negative 2 from the first equation or negative 3 from the second equation. And this is what the solution would look like to this equation. So if we wanted to solve that equation, we're looking for the values of x that would solve that equation. And those values are x is equal to a negative 2 and a negative 3. So we found the solution to that original quadratic equation. Now, we're going to do the same thing here, but for larger polynomials. Let me go ahead and point out that there's some terminology that we're going to be using for polynomials. A polynomial is something that looks like this, maybe 3x to the 7th plus 2x squared minus 3x. That's a perfectly good polynomial. The degree of a polynomial is the highest power that occurs in that polynomial. So this is a degree 7 polynomial. And monomials, mono meaning 1, monomials are just the individual terms in a polynomial. So monomials would look like 3x to the 7th or a 2x squared or a negative 3x. The individual terms in the polynomial above would be called monomials. So this is a monomial, this is a monomial, and this is a monomial. So they're all just the individual terms. A polynomial is a bunch of those in some linear combination, so you can add them together. Now we're going to look in this set of notes at solving polynomial equations. A polynomial equation is something like this. So maybe let's go ahead and start with example 1a. Just like quadratic equations are of the type that we saw up at the beginning of this set of notes, so this is a quadratic equation. Polynomial equations are very similar, it's just that this time we're allowed to use polynomials rather than just quadratics. So a quadratic, remember, was a degree 2 polynomial. Here I can use any sort of polynomial that I want. So in example 1a, we're looking at 5x to the 4th minus 20x squared equals 0. So in this case, I have this degree 4 polynomial over here on the left, and it's supposed to equal 0. And the goal in any of these equations is to find all of the values of x that you could plug in that would satisfy this equation. Okay. Now, the procedure that we're going to be using is written up in the middle of this page on your notes. I'm not going to rewrite the procedure here because I think it'll be more useful to just do a hands-on example with it. But if you want to look at the general procedure, then you can just read through the notes in this section. But a good first step when solving equations like this is to make sure that you've rearranged so that all of the non-zero terms are on one side and you've got a 0 on the other side. This is something that we already did for quadratic equations. The next goal is to factor this thing on the left. So we want to factor this polynomial for the same reason as in the previous example. So we still want to break this into a bunch of smaller pieces so that we can set each of the individual factors to 0, and that will find all of the solutions that we need. So a good first step when trying to factor something is to see if there are any common factors between all of the individual terms that you have. So notice that 5 is a factor of both of these terms, and x squared is a factor for both of these terms. So I would start by factoring out a 5x squared. And if you divide that first term by 5x squared, what will be left over is just an x squared. And if you divide that second term by a 5x squared, what would be left over is a negative 4. So that left side factors as 5x squared times x squared minus 4. And then the right side stays 0. So this is still a polynomial equation. In this case, it's still a polynomial equation of degree 4. We haven't changed the degree of the polynomial. The total degree is still 4. So this is still degree 4. But what we have done is we've broken this up into some smaller pieces. And the goal is to factor this as much as possible. Now, x squared you can't really factor any further, so you could write this as 5 times x if you wanted to split those, but they're basically the same factor, so it's more convenient to just leave that as an x squared. But it's okay to write that first term like that, or that first factor. We can, however, factor x squared minus 4 in a convenient way. X squared minus 4 factors like this. So maybe actually let me erase this. I'll go ahead and write the factored form. So x squared minus 4 factors as an x minus 2 times an x plus 2. So you can split it into those two factors, and we'd still have an equals 0 on that right-hand side. Now, in case you aren't comfortable factoring that x squared minus 4, let me show you two ways that you can see that factorization works. So let's say you're trying to factor this x squared minus 4. One way of doing this is to use this difference of squares pattern. So anytime you have an a squared minus a b squared, that can always be factored as a minus b times a plus b. And I'm applying that factorization here with an x squared and a 2 squared. So I have an x squared minus a 2 squared, so that would give me an x minus a 2 times an x plus 2. So this pattern holds true in general, but we can also factor this using the technique that we saw earlier. So we could alternatively think of this x squared minus 4 as being an x squared plus 0x minus 4. And then we're looking for two numbers that multiply to give a negative 4 and that add up to a 0. And those two numbers should be a negative 2 and a positive 2. So this would factor as an x minus 2 times an x plus 2. So either way, we get this factorization done here. Okay. So that means that the factored form of this equation is a 5x squared times x minus 2 times x plus 2. And this still equals 0 on the right-hand side. And the benefit of doing this is that now we have this broken into 3 different factors. And when we have a product that equals 0, what we know is that at least one of those factors has to be 0. So this means that either 5x squared equals 0, or x minus 2 equals 0, or x plus 2 equals 0. Now this first equation would imply that x has to be 0. So this means that either x equals 0. The middle equation would imply that x is equal to a positive 2. And then that last equation would imply that x is equal to a negative 2. And these are the three solutions that we find. And any of these would solve the original equation. One benefit of this kind of problem is that you can check your answers. So we have a 0, a 2, and a -2. We can plug in all three of those into the original equation up top just to check that our answers are good. So for example, if we plugged in a 0, we would get a 5 times 0 to the 4th minus 20, 0 squared, and that's supposed to equal 0, and that is true. And you would find the same if you plugged in this +2 or -2. Okay, so that's what we want to do whenever we solve these polynomial equations. If you want to solve them by factoring, then what you do is you factor as much as possible. Generally, you want to factor them into these distinct linear terms like this. And then you can identify the root for each of those individual linear factors like we did down here. Okay, and that finds all of the solutions, all of the values of x, maybe I should say, that you can plug in to solve the original equation. Okay. So let's try to do something similar in 1b. This time there's a slight complication. We have x plus 1 is equal to a 9x cubed plus 9x squared. Now, a good first step in these problems is to rearrange so that it looks more like the previous examples. What I mean by that is that we want to rearrange so that there's a 0 on one side of the equation, because it doesn't benefit us to have a factored form on both sides of the equation. We want a 0 on one side of the equation and then a factored form on the other. So I'm going to move these to the right-hand side by subtracting an x from both sides, and also by subtracting a 1 from both sides. So if I do that, the left side will become a 0, and the right side will become a 9x cubed plus 9x squared minus x minus 1. Okay, now here there are 4 terms. There's only one strategy that we're going to talk about in this class for factoring polynomials that involve 4 terms, and that strategy is called factoring by grouping. The idea is that I'm going to group these first terms together and also group the second terms together, and I want to factor out any common factors that I see between each of those pairs. So notice that this first pair has a 9 in common and they have an x squared in common. So if I take that 9x squared out from the first pair, the remaining factor would be an x from the first term and just a 1 from the second term, because if I divide that second term by 9x squared, the only remaining factor is a 1. And then I can factor out what these last terms have in common. Now, it's okay to say that these terms don't really have anything in common. They basically only have a factor of plus or minus 1 in common. But if this first term is negative, I like to factor out a minus sign from both of these terms. So I would factor out a -1. And when you factor out that -1, what you'd be left with is an x plus 1. Okay, so now we've factored both of these groups. Now we just have 2 terms. We have this term and this term. But notice that these 2 terms now have a factor in common. The factor that they have in common is an x plus 1. So if we factor that out, what we would get is a 9x squared minus 1 as the remaining factor. And now we've factored this into these nice 2 factors. So we have 0 is equal to x plus 1 times a 9x squared minus 1. And now our goal is to solve this equation. Now, we can further split up this last quadratic factor into 2 pieces. One way to split this up would be to maybe use the difference of squares formula that we saw up above. So this is a 3x squared minus a 1 squared. So this is a difference of squares, and that means that I could write this as a 3x minus 1 times a 3x plus 1, using the same information that we used up above. We're using the fact that anytime you have something squared minus something else squared, you can rewrite it as a minus b times a plus b. So we can use this difference of squares factorization again here. I'll show you the alternative to doing this if you don't like using that difference of squares in just a second. But notice that if you do factor it like this, then because we have 0 is equal to this product, we know that 0 is equal to at least one of these individual factors. So 0 is equal to x plus 1, or 0 equals 3x minus 1, or 0 is equal to 3x plus 1. And then by solving each of these individual equations, what we get are the three options that would satisfy our original equation. So the three options that I see are a -1 as our x value for this first equation, a 1/3 as the x value that solves the middle equation, and then a -1/3 as the x value that solves that equation. And if you want to use some scratch paper to solve these equations by hand, then you're welcome to. So for example, in this last equation over on the far right, you could subtract 1 from both sides. That would give you the new equation, -1 is equal to 3x. And then you can divide both sides by 3 to get x by itself. That would tell you -1/3 equals x. So you can solve these out by hand if you'd like, but if you can just spot the root immediately, then it's okay to just cut straight to the answer. Okay, so that's one way of getting the three solutions. This is the answer that we're looking for. There is another way that we could, or maybe I should say another approach that we could take if you aren't comfortable using this difference of squares formula. I think the difference of squares formula is the nicest way of doing this. But another way that you could do this is to go back to this step. So maybe let's look back up here. Now here we have 0 is equal to this factor times this factor. So let me rewrite that down below just so that we can see this alternative strategy. So maybe let's say we were attacking this problem and we didn't know this difference of squares formula. Could we still solve this? The answer is yes. We know that either this factor or this factor has to be 0. So we would have 0 is equal to x plus 1, or 0 is equal to that second factor. Now this time we didn't fully break up the second factor. So we know that this second factor could be factored a little bit more. But even still, we can solve both of these equations that result from setting each of the individual factors above to 0. This first equation would tell us that x is equal to -1, like we saw before. This second equation is a quadratic equation. And so we could solve this using any of the methods that we've talked about for solving quadratic equations. But in particular, you could maybe use the quadratic formula here. So here, I would treat this as a 9x squared plus a 0x minus 1 equals 0. So 9 would be the value of a, b would be 0, and c would be -1. If you plug those in as your a, b, and c into the quadratic equation, I won't do the scratch work, but you'll get that x has to equal plus or minus 1/3. And that, again, recovers the two solutions, well, really three solutions that we had up here. So either of these methods would work. I would recommend just fully factoring anytime that you can, but it is okay to just apply the quadratic method anytime you have a quadratic that's set equal to 0. Okay, so this is the general strategy that we're going to take whenever we're trying to solve polynomial equations like this. We want to try breaking up the equation by factoring that left-hand side. Okay, and I'll post these notes online. So you'll have access to this, but I would recommend reading over the typed up notes as well, because there's another example that you can read from the notes that's maybe a little bit neater than what we did here. But hopefully this was helpful. I'll try also finding some online resources, but feel free to email me if you have any additional questions about this stuff. All right, thanks.